Hello, this is Professor Kuehn. As I mentioned before, my lectures on astronomy are broken up into three basic units. The first one being on ancient and medieval cosmology, primarily geocentric cosmology. The next unit is early modern cosmology, primarily heliocentric cosmology. The third and final unit is on modern cosmology. So what we are doing right now is we're filling in some of the gaps between where we ended with early modern cosmology and when we are picking up with modern cosmology. In my last lecture, we talked about the work of Isaac Newton, his universal law of gravitation. And we very cursorily or very quickly looked at this law and how it provided a new way of understanding the ancient term gravity. If you want to hear more about Newton's universal law of gravitation, I'd highly recommend that you take a look at my lectures on space, time, and motion. That's my Physics 151 and 201 course. In any case, as I mentioned in my last lecture, Newton, at the end of his Principia, this is around 1700, he was speculating about the distance to stars. That is, how do we know how far away the stars are? And at his time, there was no way of measuring precisely how far away the stars were. Rather, there was a method, but it just wasn't accurate enough. When would it become accurate enough? Well, now we're going to look at the work of Friedrich Bessel. Friedrich Bessel in 1838 was the first one to measure accurately the distance to a nearby star. Telescopic techniques had improved by this time, and he measured the distance to a star called 61 Cygni. It's actually a binary star, and it's located in the constellation Cygnus, with which you're probably familiar. He found that 61 Cygni is about 11 light years away from the Earth. How did he do these measurements? Well, he used a technique called parallax. This is a well-known technique. You're actually familiar with it, and if you want a demonstration of how this works, you can hold up a finger in front of your face. I think I might have explained this to you in lecture before. If you hold a finger at arm's length in front of your face and close your left eye, and note where your finger is with respect to the room behind it, and then you close your right eye and open your left eye, and you go back and forth like this, you'll see that the position of your finger seems to hop back and forth between two different locations. And how much it hops back and forth depends on how far away your finger is from your face. So if you were to hold your finger very closely and you were to do the same thing, opening and closing your two eyes, you can see it hops back and forth from your perspective through a larger angle. In other words, the amount of hopping, the amount of angular hopping that you see your finger undergoing depends on the distance to your finger from your eyes. That is the method of parallax. It's a way of finding out how far something is away from you by looking at it from two different perspectives. That is precisely the method that Bessel used in order to measure the distance to 61 Cygni. Let me draw a picture. Suppose we think about the sun being right here, and the Earth is orbiting around the sun. So here is the Earth. Actually, let's make the Earth a little bit closer. So here is the Earth right here, and I'm going to draw the orbit of the Earth around the sun like this. And so let's suppose on the winter solstice it's over here, and on the summer solstice the Earth is over here. So these are the two different locations at different times of the year. Now let's suppose the stars are very far away. I'm going to draw a number of stars very far away from us, like this. And I'm drawing a lot of them that are at the same distance but very far away. But let's suppose that there's another star. I'll draw it in orange that's considerably closer than the rest of the stars. Let's suppose it's right here. And let's suppose that you look up at this star at a particular time of the year when the Earth is over there. Let's say that was the winter solstice. That star would appear in this region. That is, it's kind of near stars 1 and 2. But let's suppose you were then to wait 6 months and observe this nearby star once again, and now, because the Earth has moved, now that star appears in front of stars 3 and 4. In other words, its apparent location with respect to the much more distant stars has changed, much like opening and closing your two eyes made your finger appear to hop back and forth. The Earth rotating around the sun makes this star appear to hop back and forth. And by measuring the angle of hopping, that is, the angular deviation of this as the Earth goes around the Sun, one can discern how far away that star is. So one can discern the distance to that star, but one would need to know the angular hopping, the amount of angular hopping, and also the diameter of the Earth's orbit. Friedrich Bessel was able to measure the distance to 61 Cygni to be about 11 light years. Remember, a light year is the distance light travels in 1 year. There's a way of describing how far away stars are using this method, and it is in terms of parsecs. Okay, so 1 parsec, that's short for 1 parallax second. Remember, a second is a measurement of angle. So there's 360 degrees in a circle, there's 60 minutes in a degree, and 60 seconds in 1 minute. So 1 second is a very small angular measurement. And 1 parsec is the distance that a star would have to be so that when the Earth goes around the Sun, it hops through an angle of 1 second. So I'll write that down. So 1 parsec is equal to the distance d such that the angle theta is 1 second of angle. 1 second of angular measurement. Okay? And what Bessel was able to find out is that this star, 61 Cygni, is about 3 to 4 parsecs away. So 61 Cygni was about 3 to 4 parsecs away. So a parsec is not just something that's used in Star Trek and other sci-fi movies. It's actually a legitimate measure of distance. Okay, now it becomes apparent through Bessel's measurement that different stars are at different distances from us. Okay, and as the stars are farther away, it becomes more and more difficult to measure the distance to them using this parallax method. Because as a star is farther and farther away, as the Earth goes around in its orbit, that angular deviation of this planet or this star compared to the background stars is going to get smaller and smaller and smaller. And in fact, once a star gets more than about 100 parsecs away, it becomes practically impossible to measure the distance. So there's kind of a limit on how far something is away before the parallax technique becomes impractical. Now, 100 parsecs seems like a very large distance, but in fact, our own galaxy, the Milky Way galaxy, that is all of the stars that are closest to our sun, that Milky Way galaxy is about 30,000 parsecs across. So even if you can measure out to about 100 parsecs of distance, you could only measure to the very nearest stars even within our own Milky Way galaxy. There is no way to use the parallax method in order to measure the distance to the stars on the other side of our own galaxy, let alone the stars that are located in other galaxies. So that might raise the question for you, how do we know how far away the distant galaxies are?